So welcome back, guys. In this second video, I'm going to start from question number 6, and I'll try to do at least 5 questions in this lecture. Then we'll be moving towards question number 11 and onwards. So question 6 says that let f be a real valued function such that f of x is equal to x for all real numbers x in the domain of f. Which of the following could be the graph of f in the xy plane? So the condition that is given to us is f of x is equal to x. And we can write this thing, like we can take this f on other side, or we can operate f inverse on both sides. Then we get that, okay, f of x and f inverse of x are same. So the function and its inverse are same. So how can we see this thing? So a function and its inverse is always a reflection along the line y is equal to x. So for example, if I put line y is equal to x in this graph, it would look like this. This is line simply y is equal to x, and here y is equal to x. Similarly, y is equal to x, and y is equal to x, and here y is equal to x. So now you have to see that, okay, which graph is some sort of reflection of itself along this line y is equal to x. So obviously, like this is not the option clearly, because we don't have anything on the other side of the line y is equal to x. There should be some sort of reflection. And this is not the correct option, as the line on either side is going to be different. It's not going to be the reflection. And this is also, option C is also not correct. The reason is the reflection of, let's say, this part should be something like this. Something like this. Yeah. Or maybe a little bit like this. But it's not exactly the same that we need. Similarly, you can see question number, sorry, option E is not correct as well, because if we have this thing here, its reflection along this line would be, I think it would be something like this. Reflection of this one, and it would be something like this. But you can see that if you reflect this line, it becomes exactly this. If you reflect this line, it becomes exactly this. So seemingly, like when you see this line has a reflection, this one, or this line has a reflection, this one. So f of x and f inverse of x are simply the same functions. So f of x and f inverse of x are same in this case only, that we have option D. So our correct option is D. So it's simply the idea of a function its inverse, which is like simply the reflection along the line y is equal to x. Okay, so let's move ahead. So now it's MCQ number 7, which say that if a and b are positive numbers, then what is the value of this limit? We'll apply the standard result that says the limit x goes to, I think it should be x goes to infinity, 1 over 1 plus x to power x is equal to e. This is a standard result that we know, or we can rewrite this result as, okay, x goes to 0, and here 1 over x becomes x and x becomes 1 over x. This is another standard result that we can use. So what I can do, I have to cancel out this a. So I'm just substituting x over a equals y. This is my simply some sort of transformation. So this becomes limit y goes to 0, because if x is 0, then y is going to be 0 as well. and this becomes 1 plus y to b over x. So what is going to be the value of b over x? It's simply b over, the value of x from here is going to be a times y. Yeah, a times y. So this is going to be a times y. So I can write this thing limit y goes to 0, 1 plus y, 1 over y to power b over a, because I can take exponent outside of the limit. Yeah, so b over a. Yeah, so this limit is going to be e. So my final answer is going to be e to the b over a. So it's option B, e to the b over a. It's simply this result that we are using. There's nothing else. So this result is being used to give us this answer by using some sort of transformations like this. Very simple. Question number 8 says that if a function is defined by f of x is equal to log x over x square minus 1 for all positive numbers except at x is equal to 1, because this function is not defined at x is equal to 1. But the value of function at 1 is by default given to be a. For what value of a is f continuous at x is equal to a? So there is a simple condition for continuity. We know very well that, okay, the value of the function at 1 should be the limit of the function as x goes to 1. So the value of the function and the limit of the function should be same. This is some sort of like condition to check continuity at a certain point. This is not the definition, the epsilon delta or something else. This is simply the condition to check the continuity of a function at a given point. So fortunately, we are given the value of the function at 1, that is a. We have to find out the limit of the function as x goes to 1. So limit x goes to 1, the function is log x over x square minus 1. So simply you can see that if I substitute directly x is equal to 1, the numerator becomes 0 because log 1 is 0 and the denominator becomes 0. So this is 0 over 0 indeterminate form. So we have a theorem, what we call L'Hopital rule, that we can apply to find out the limit. So L'Hopital rule says that you have to differentiate the numerator and denominator. Differentiate numerator, denominator, there's no quotient rule. It's just a derivative independently. So the derivative of log x is 1 over x. And the derivative of x square minus 1 is 2x. So this becomes limit x goes to 1, 1 over 2x squared. Now, if you substitute 1 directly, then there is no any 0 in the denominator, then it makes sense. So the final answer, when you substitute 1 here, you are getting 1 over 2, which is going to be the value of a. So the value of a is going to be 1 over 2, which is option B. Very simple. It's just L'Hopital rule and the definition of continuity of a function at a point. Not the definition, maybe a property. Okay, question number 9 is related to probability, where it's simple as well. So of the 10 light bulbs in a box, 3 are defective. So I'm writing the data. 10 total bulbs, out which 3 are defective, and obviously 7 are going to be non-defective. 2 bulbs are to be chosen. So the total number of sample points in the sample space is going to be 10 choose 2, because you have 10 and you are going to choose 2 out of that. So I'm going to simplify this thing, 10 factorial over 10 minus 2 factorial and 2 factorial by using the formula of combination, because this is total number of sample points. This is, we have 10 and we are going to choose 2. So 10 factorial and 10 minus 2 is 8 factorial. 2 factorial, which becomes, so 10 factorial. Sorry, let me simplify this. 10 times 9 times 8 factorial divided by 8 factorial, and 2 factorial is 2. This is cancelled. So by applying table of 2, total number of sample points is 45. Now let us read the question ahead. From the box at random and without replacement. It means we are choosing and we are not going to replace back the items that we have chosen already. What is the probability that at least one of 2 light bulbs will be defective? So we have to choose 2, at least one is defective. So either one is defective or both of them are defective. So number of sample points in the event would be one is going to be, at least one is going to be defective. So defective are 7. 7 choose 2, 7 choose 1 because 1 is defective and 1 is non-defective. 3 choose 1. So here this one shows defective and this one shows, this is non-defective and this is defective. Plus, so one is defective or both of them are defective. So 7 choose 2 and I have to multiply 3 choose 0. But 3 choose 0 doesn't matter. I can multiply. So out of 7, if you choose 1, so there are 7 choices. It's very simple. You can apply the same formula of combination. Times 3 choose 1 is 3 plus 7 choose 2. I think we should do this. 7 choose 2. Yeah, let me do it. 7 factorial over 7 minus 2 factorial, 2 factorial. I could have written this, but 3 choose 0 is 1, so I'm not writing. So 7 times 3 is 21. And plus 7, not 7, 6 factorial, no, 6, wait. So 7 times 6 times 5 factorial over this denominator is 5 factorial, 2 factorial is 2. This is cancelled, this is 3, 7 times 3 is 21 plus 21. So this is 42. Yeah. So what is the probability that at least one of the 2 light bulbs will be defective? Oh, sorry. I think I'm mistaken. So defective are 3. So wait. I have to remove this thing. So this should be 3 choose 2 and 7 choose 0 because 3 are defective. So I have at least 1 defective or 2 defectives. 3 choose 2 is same as 3 choose 1, which is 3 times 1. So 7 times 3, 21 plus 3 is going to be 24. And the probability of event is number of elements in event E divided by total number of points in the sample space. So this is 24 or 45. I think reducing it, I simply applying the table of 3 is going to be 8 over 15. Yeah, so it's option C. So if you have practice of these questions, it takes less time. Otherwise, like sometimes you are screwed. So you should be good at these. You should have a good practice. Like I'm not doing practice at all of these, all the things. So you can see I master a little of these things. But if you do the practice, you can make sense of these, all the things. So it depends, all it depends upon the practice. Okay, let us do the last question for this one. It is question number 10. I think I have enough space here to do this question. Only I have to do is to write this function in this series, and I have maybe a couple of ways to do this. And I have to evaluate these coefficients A0, A1, and A2. So what am I doing? I'm writing the function, which is 1 over 1 minus x square and I'm evaluating this at 0 because this series is Maclaurin series or the Taylor series evaluated at x is equal to 0. So then I have to evaluate this function at 0 because the general series is x minus a to the n and a n. This is the Taylor series around x is equal to a, but this is like here a is replaced by 0. So f of 0 is going to be 1. And then I have to prime it. It's simply the derivative. So I'm not going to tell you the whole process to differentiate because it's too simple. But let me think for myself what is going to be the derivative. Oh, sorry. This is this. Yeah, f of 0 is 1. And f prime of x is 2 over 1 minus x to the cube. And if I evaluate f prime of 0, this is going to be 2. And f double prime of x is 3, yeah, 6 over 1 minus x to the 4, and f double prime at 0 is going to be 6. So these are the values of the derivative. So these are not going to be the values of all the a's because we know very well what is going to be the Maclaurin or Taylor series for a function. So for a function, the Maclaurin series is f of 0 plus x times f prime of 0 plus x square over 2 factorial f double prime of 0. Because I need only 3 coefficients, so I'm not going beyond this. So f of 0 is 1 plus x f prime of 0 is 2 plus x square over 2 factorial f double prime of 0 is 6. So simply I have, like, I can go beyond this. But I have 1 plus 2x plus 3x square because 6 divided by 2 factorial is 3. So you can see my first coefficient is 1 and then 2 and then 3. So 1 is going to be the coefficient of x power 0, 2 is going to be the coefficient of x power 1, and 3 is going to be the coefficient of x power 2. And these are my values a0, a1, and a2. And I know I need only these values. So 1, 2, and 3. Yeah, so this is option B, 1, 2, and 3. Okay, I think this makes sense, but if you want, you can go for other way, and the other way, let me give you in a quick way. So I have 1 over 1 minus x whole square, which I can write 1 over 1 minus 2x plus x square, just expanding. So I'm dividing 1 by 1 minus 2x plus x square. So I have to multiply with, it's just simply the division. 1 minus 2x plus x square. And then you have to subtract. This becomes 2x minus x square. Then just multiply this 1 by 2x. So this becomes 2x minus 4x square plus 2x cube. Then you have to subtract. This becomes 3x square minus 2x cube. Then you have to just go ahead and multiply this by 3x square, and you can see the 3 terms that you got are same as this. But this division is sometimes tedious because you have to take care of everything. So I don't encourage you to go for this. So the Taylor or Maclaurin series is a very good option for this. Okay, so see you in the next video where I'll start question number 11 and like 11 to 15 maybe. So goodbye till then.